Welcome to Geometry Quiz number 5 review, After Dark. I'll be your host, Mr. Mac. Okay, with a few interruptions by Crane Carroll, which is totally fine. Totally fine. So if you got questions about, is this the assignment I'm missing? Yeah. Okay. All right, so, mortals, welcome. Here's our goal. We want to take this and prove that, which is totally bizarre, because like that's not how you subtract fractions. But it's true. When the numbers are all the same, right, when the fractions are all equivalent, this is true, and I'll prove it, right? Give me some numbers for A and B. Give me some numbers.
2 out of 3.
2 out of 3. I need equivalent fractions to 2/3.
Wait, no, never mind.
Well, if you times both top and bottom by a number, you'll get equivalent fractions. So give me a number.
4 and 6.
4 and 6, and how about 8 and 12? Right? Cool. They're all equivalent fractions. Right? They're all 2/3. So I'm going to prove with these guys that this totally works, and then I'm actually going to do the proof, okay? So, hold on, I got an email. Maybe your mom. Shout out to Corinne's mom. It is Corinne's mom. She says thank you. You're welcome, Corinne's mom. Anything for the moms. Alright, so. Is it true that when we take A and C and subtract them and B and D and subtract them, we get EF? Well, let's do it. 2 minus 4 and 3 minus 6. Again, not how you subtract fractions. That's not how, okay. So, do we get this? Well, 2 minus 4 is negative 2. And 3 minus 6 is negative 3. Well, 2 negatives cancel, right? So we get 2/3. Is 8 out of 12 2/3? Oh yeah, because we divided by 4. It does. It's bizarre, but it's true. This is why we call it a lemma. Because you're not actually like, this isn't something I really care that you know. It's just something that you need to know before we go on. You need to know that algebra works this way, okay? So we're going to prove it, that it works for all numbers and not just the numbers I chose, because like, I could have done that. I am pretty sinister. Please. Okay, thank you. All right, so here's what we're going to do. I'm going to write this nice and big. We're given that this is true. Right? That's a lot of equal signs. What we want is this. So this is kind of a really complex goal to get to out of this, so I'm going to break it down so you can see what our goal should be. I'm going to treat B minus D as a number, and I'm going to multiply it over. Is that equal with that? Bueller? We good? Key 10? Great. Cool, I went from there to there. Totally rad, totally fine. So my goal is more defined now. I'm gonna find what A and C are, and then when I subtract them, this should happen, right? So I want to get A on its own, and I want to get C on its own. Now, not only do I want to get them on their own, but I want E, F, B, and D to be on the other side of the equation. So when I get A on its own, I'm not going to move over the B and get this, because I've got B and D on the other side, but I've also got C, and I don't want C, right? I don't want to get C on its own like this, because then I've got C on its own, but I've got D, A, and B on one side, and I don't want that, right? So what I'm going to do is I'm going to get A on its own by moving the B over to here, okay? And that's going to give me B, E, and F. That's good. I want those things, right? And I'm going to get C on its own by moving the D over to here, because that gives me D, E, and F, which is good, because I want those things, right? So I'm going to take one at a time. Totally true statement, right? Cool. How am I going to get A on its own? What am I going to do, Keaton?
Multiply.
Yeah. Both sides, otherwise it's child abuse. So what we get is A equals, multiplication happens in the top, division happens in the bottom, right? So we get B, E over F. Hooray, we know what A is now. Great. Now let's find what C is. Right? So how do I get C on its own, Natalie?
I don't know.
Well, I need to get rid of divides by D. So what should I do?
Multiply.
Yes! That's absolutely right. So C is going to equal DE over F. Oh, great, 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 great. This is good news. So we now know what A and B, or A and C equal. And so now when we subtract them, we're going to know what they equal. We're going to know what happens. Check it out. What happens when I subtract A from C, or C from A? Well, that's the same thing as this minus this, right? If I do A minus C, that's the same as this minus this. Whoa, that was fast. Whoa, whoa, whoa. That was really fast. Good job, I think. I don't know, reading's hard. Okay. Are we good with that? Alright, cool. So we get common denominators, right? If I've got two fractions that are subtracting and they have common denominators, like, I don't know, 4/3 minus 1/3, right? They're both thirds. Right? So I can have common denominator, subtract the top, right? I get 4 minus 1, which is 3. Cool. Common denominator means I can write it like this. BE minus DE. Cool? Awesome. Corinne, do you need my help or no?
I think this is.
Everything?
I don't know.
Okay.
Because I separated it from like reviews and warm-ups and my graph paper sheets. that we did.
Alright, it's gonna take me like 3 more minutes to get through this, and then I'll look through all of them and we'll get you out of here, okay?
I have time. But
Okay. Alright, so now we're here. Now it's good. I want to get, ideally, E and F away from B and D, right? So what I'm going to do, they didn't teach this in middle school because you weren't old enough to handle it, but the opposite of distribution is pulling out. It is a valid strategy in math only. So check it out. I pulled out an E from both, right? And that E, if I were to redistribute it, it would go EB minus ED, right? And then the divides by F, I just put it on the side. Totally valid, totally works, okay? Totally valid in math. We good with this? Awesome. Now, that got me to here, that's great, but my real goal was here, right? So, to get from here to here, I multiply by B minus D, right? So to go back, what would I do? Corinne, if I multiply by B minus D to get here, to move it over, what would I do to put it back? Thank you. And when I do that, I get what I wanted to prove. Ta-da! I did it. So you don't need to show any of this stuff or like this, right? All you need to be like is, look, I want to get A and C on its own. How do I know? Because secretly Mr. Mac showed me I need to get A and C on its own. Or maybe you actually do understand what I'm talking about, right? Your call. So you need to get A and C on its own. You do that. Then you subtract them because that's what you want to know, right? And this happens, and then we move it over. Turns out it's true. How do we feel about this? Let's talk about our feelings. How do we feel? Gucci? Would you describe your feelings as Gucci? About freaking fantastic. No, okay. But Gucci? How about Dees? Okay. Get A and C on its own. Do math. It's gonna be weird. You're gonna have to pull out. But it's gonna be fine. I don't know why you're laughing. What do you want me to do? Go on? E-ban! You ready to move on? None of you were thinking of Corinne. Not a single one of you is thinking of Corinne.
I'm not in this.
I'm disgusted. Alright, so which ones did it say that you needed?
I don't know. It didn't like tell
What?
me I could get there, but I did just pull out everything that we didn't do.
Okay.
That's
I don't need the
everything
quiz
that I'm
reviews
pretty
ever.
Sure I didn't do. So.
Yeah, that would be a lot of things. Oh my god, Corinne.
What?
That's a lot of stuff. Okay, yeah. let me take all this and I'll sort through it. Actually, let me check right. Guys, pause for a second now that I have all these in front of me. I'm going to sift through the gradebook and see which ones are relevant, which ones are not. Priority grading. Wow. Wow.
I just don't know which ones
I understand.
do that.
I understand. Oh boy. Alright, so Corinne. Triangle congruency, yep, that was missing. Now it's not. Corinne, missing reflection week 3. You turned that in, I just haven't checked it yet. I saw you post it.
I went there and did all the reflections.
That's
I
good.
don't know if it was
Did you BS it? Because I'm trusting you that you didn't. I will go back and check this weekend.
I actually never do, even if
I know
do
you
it all
don't.
in
I
one
really
day.
like your reflections. Median worksheet. Median's worksheet. Okay, I don't have median's worksheet. Can you find that?
Well, here's one of them, but this is a review, so.
Angle bisector in center worksheet. Yep, angle bisectors, we've got that. It's the most wonderful time. Alright, and then lots more of those.
Was
Corinne.
it this that we did? Like,
It's medians. It's a Kudo worksheet. It's like one of these guys.
yeah. I think I just saw that.
Medians. Oh, you need to take a quiz that you never took. You never took quiz 3. Or maybe you did, but I just haven't graded it. But did you take quiz 3?
I think so.
Okay. You know your crap. You could pass it right now if I gave it to you.
Yeah. Is it? But this is somewhere. Did we do anything that Friday that I didn't get? Or
We might have. It might have been a Friday where we did a quiz, and that's why you haven't taken the quiz. And that, yeah, that would explain it. You didn't take the quiz, and you didn't turn in all that homework that you owed me because you weren't here to turn it in. That's similar triangles. I need a medians worksheet. It should say medians.
and it's Kudo software.
Yep. Okay, calm down, Heather. Relax. Alright, so yeah, all these are things that I need. And they're turned in now. But yeah, I need the medians worksheet. If you can get me the medians worksheet and take that quiz, then you're golden. Would you like to take quiz 3 right now?
Can I look at it and see what it's over to see
I
if
can give you the
remember
review
it?
guide and you can take a look at that, yeah.
Oh, this? This is one like we. Like you gave
Medians,
us all
yes.
the.
Answer keys too?
Yeah.
Yes, I
but-
give you the answer keys so you can check your work. I just need to see the work. So if you want to complete that right now and then do the review guide, you'll be gold. Alright, I'm back, guys. Sorry. Alright. Are you ready? The real work begins now. We're gonna prove Seba's theorem. What is Seba's theorem? That's a good question. I'll tell you what it is. I'll tell you. It's when the cedians of a triangle are concurrent. What does concurrent mean?
Similar.
The what?
Similar.
No, that's congruent. What does concurrent mean? I swear to God.
Wait, can you move your hand? Oh. Okay.
I'm glad that helped. Alright.
Oh, is it when they cut it?
Somewhat. It means they all intersect at one point.
I had it close.
Right?
It's close.
So like, these lines would be concurrent. These lines would not be concurrent. So, if the cedians, what's a cedian? It's any line that goes from a vertex to the opposite side, right? Okay. If they're concurrent, which they is, then the way they divide up the triangle into little pieces, right? That's all gonna multiply to 1. So the ratio of the bases, right, are all gonna equal 1. Words are hard, math is easy. You go around the circle and equal 1, okay? So, here's what we're going to do. There was a lemma that we learned that isn't in this review packet that says that the area of a triangle compared to the area of another triangle, if they have the same height, they'll be proportional. So let me say this. Notice that this triangle here and this triangle here have the same height, right? ACD and BCD have the same height. They're the same height. Keaton, who are you the same height as? Okay, well, if you were a triangle, your area will be proportional to that other person's base. That's amazing, right? Isn't that amazing? So these two triangles, they're proportional to their bases. Amazing. So I'm going to write that. The area of this triangle, triangle ACD, the area of triangle ACD is proportional to the other triangle. So ACD and BCD both have the same height, right? So they're proportional, their areas. Grand, fantastic, great, Gucci. All right. To their bases. Keaton. ACD has what base?
A.
Little a, that's right. And then BCD, Natalie. BCD has what base? Our favorite rapper.
Favorite rapper?
Yes.
What?
Lil B.
Oh, it's a little B.
Lil B. You got it, right?
Yeah.
All right, so. Now.
Did you know I'm a song?
No.
rapper? Okay.
Actually, yes.
Yeah, my name's Lil Natty.
That makes sense. All right. Notice that there are other triangles in this diagram, Keaton, that have the same height and have base A and B as well. This triangle, Keaton, ADG, has base A, and it shares a height with BDG. They're the same height, Keaton, so imagine you being the same height as someone else. If you were a triangle, your area would be the same as, it would be proportional to the bases. It's like your feet would be the same as another person. Isn't that weird? It's weird. All right. It's a proven mathematical fact. If you were a triangle, so ADG, that's this guy, Keaton. And then this one, that's BDG. I do alphabetical order when I can, as we all should, as good Christians. That was a joke. That was a joke. Okay. So, all right. Shout out to my Jewish brothers and sisters. All right.
That's me.
That's right. For real?
No.
Oh, darn. I have a yarmulke on one of my coat jackets. I can't remember which one. My suit jackets. I gotta bust it out. All right, so. Okay. Now, don't we have three fractions equaling each other? Remember lemma number 1. It says we can take 2 of those fractions and subtract them in that weird, totally not legit subtraction way, and we get the third guy, right? So I'm going to do that, Keaton. That's allowed. We proved that earlier. So I'm going to say that, look, dark blue triangle minus, well, the light blue triangle, Keaton, the tops, right? Over the bottoms subtracted. They're subtracted, these triangles. And even after you subtract them, they're still going to be equal to A over B. That's just wild. It's wild, but it's true. But you're asking, who cares? Right? And that's a great question. Even better question, what does it mean? Well, big triangle's this guy, right? Right. And if I subtract this guy, what's left over? This one, Keaton. This triangle, right here. The one that's the white triangle, AGC. Or ACG if we're being alphabetical. So in other words, that just stands for ACG. So like why use all those letters? Let's use less letters. ACG. Right? That makes sense. That makes sense. That checks out. Okay, so BCD is this big triangle, right? And I'm gonna subtract this bottom guy, and what's left over? Well, triangle BCG, right? You follow me on that? Awesome. So that's rad. And that'll also equal A over B, right? Because it's just this guy switched out, right? Now that's what we want, because now we know what A over B equals, and it's actually going to cancel a bunch of stuff for us. Trust me, these triangles here and here are going to come back. We're going to use them again. For instance, when we go for base C and base D, these two triangles, again, we use this one twice now, right? These two triangles are going to show up, right? You smell what I'm stepping in there, right? These two triangles, because this big guy goes with C, and this big guy goes with D, right? Because they're the same height. And these little guys are the same height, so they're going to go with C and D. And if you subtract them, what's left over will go with C and D. This is true. And again, we're going to use that twice, and it's going to end up on the bottom. And when we multiply things, it's going to cancel and become 1. It's going to be freaking sweet. All right, so these guys go with C and D. I'm going to say not to do this all again, because I'd rather not. These pens are $26 a pop. By same dumb logic, that's what that is, dumb with a B. Not like dummy thick, but like dummy. Okay? By same dumb logic, this and this are going to go with C and D. So this triangle is ABG. Right? You see this piece? Right? ABG? Good. It's going to go with C. Do we see that? Great. And it's going to go with this triangle, ACG, Keaton. It's going to, and that's going to go with, okay, so ABG is going to go with C, and ACG is going to go with D. Are you smelling what I'm stepping in?
Kind of.
Right? Big guy and big guy have the same height, right? And these two guys have the same height. So when I subtract big guy from little guy, get what's left over. Big guy from little guy gets what's left over. They're going to go with C and D. It's the same thing I did up here,
Okay.
just rotating the triangle.
So it doesn't matter which one you use for the first set?
Nope. It's going to work for all of them. Again, just triangles at the same height have proportional bases. Okay? Keaton, how are you? No? It's okay if you're not. So if I turn the triangle, right? Do you see how this triangle here goes with C? And this triangle here goes with D because they have the same height, right? This triangle and this triangle have the same height. You cool with that? Now, these two triangles also have the same height and go with C and D. So if I go big guy minus little guy, I get this guy left over, right? So he's going to go with C. Big guy minus little guy, it's this guy left over, so he's going to go with D. You can see that? Okay, cool. Trust me, those letters go with those triangles, the ones I pointed out. These two go with C and D. Okay? These guys. Now I'm going to do the same thing for E and F. These triangles go with E and F. You with me on that? These guys go with E and F. So I'm going to write that. Going with E is triangle BCG, right? So the area of triangle BCG, and then the area of triangle ABG. BCG goes with E, and ABG goes with F. Cool? Once you see it, it's not that bad, but before seeing it, it's like, oh my god, what? But it's cool. Notice we've not even said any proof things, like we didn't do alternate interior angles or anything, it's just like literally like using math, okay? Algebra. So now I know what A over B, C over D, and E over F are. It's time to multiply. And everything's going to become 1. There's like a metaphor there. All right. So A over B times C over D times E over F. That's going to equal this guy. Again, it's a lot of writing, alphabet soup. But after we do that first part, which was the hard part, the seeing it, right? We just copy down this stuff. And if you did it right, we're here, right? Notice that ACG's in the top and in the bottom. What's something divided by itself? 1. And what is something divided by itself? Evan, what is something divided by itself?
1.
Thank you, Evan. Thank you. What is something divided by itself?
1.
So all these are 1. What's 1 times 1 times 1?
1.
Great. You should answer 1 for every question the rest of the year. So therefore, this does equal 1, and I win.
I have a question.
Yeah.
Why do you need to know that they're co-current?
Concurrent? So turns out that when you connect certain segments in a triangle, remember like medians and like the midpoint or the centroid and all that stuff, right? We're proving that centroid exists. No matter what triangle we're talking about, there will always be a centroid because those lines will always connect.
Okay.
A type of Sevian would be like a median, right? These are general, right?
I don't know what CVN is.
So a Sevian you didn't learn about,
Okay.
it's anything that goes from vertex to the opposite side. So a median would be an example of that. It's when it goes to the opposite side and cuts the side, right? Cool. So we're going to use this to prove that the medicenter or centroid, you probably learned centroid. Centroid always exists. Same thing with the other ones. What?
We didn't learn that.
I know. Isn't it
We
wonderful?
learned SOHCAHTOA.
Yeah, we're going to do that next. They're praying to get to that.
Are you gonna use calculators for that?
No, are you kidding me? So good, no way. What's the sign of 39.7?
I don't know. I know this.
Exactly. Write sine of 39.7 and circle it and call it a day. Your method requires rounding, which means your answer is less right than mine, right? And it requires more work. Why do more work to be less right? It's like when we have 2 pi. You gonna put that in a calculator and tell me 6.28 blah blah blah? No. Why just the answer is 2 pi. Circle it. You see what I'm saying?
I know, because the textbook told us to round it.
What?
The textbook tells us to round it.
Right. So if someone really wants you to round it, right, then I guess you can. But here's my opinion on those people. If you want an approximate answer, then shouldn't the specific answer be even better? Right? You can estimate 2 pi, or you can just say 2 pi.
True.
Because if I told you 6.28 blah 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 divided by 2, you probably wouldn't realize it's pi, right?
Are you guys gonna use the law of sines?
Oh, are you kidding me? We're gonna prove it. Yep.
Then you're gonna have like a very a semi-long equation.
Mhm.
What, like
Sometimes,
a
yeah.
number be better?
Sometimes they're gross, right? But for the most part, if my kids can do it with regular numbers, I know they can do it with messy numbers, right? The hard part is typing in the calculator correctly, and honestly, I don't care about teaching that skill so much.
I don't know how Royer feels about it.
I know. If she wants to teach them how to type it in the calculator, I'm sure they'll be overjoyed about it, and then they'll learn how to do it, right? My kids also don't have graphing calculators. I think of it as like a poor people's issue. Like, I don't think it's fair to ask kids to have $100 calculator.
I use a normal one.
And that's fine, you can do that, right? But other kids might not have access to that. I try to keep it as simple as possible. Also, when you get to college math, they don't round, ever. Especially when you go further in trig. Leave pi alone, don't touch the pi. Great questions. All right, what is this? Oh, but it is Sevian's, or Seva's theorem converse. It's the converse of Seva's theorem. It's the opposite. It's the same thing we were doing before. Same thing, it's just flipped, right? Seva's theorem. Seva's theorem says if they're concurrent, then this, right? They all multiply to 1. This says if they all multiply to 1, then they must be concurrent. Now that's really useful, right? Because if you multiply the sides of a triangle up and they all add up to 1, right? Multiply to 1, then all the lines I drew actually do go through 1 point. So that's kind of rad. Here's what we're going to do. Powerful proof technique. Proof by contradiction. You know what contradiction means? It means your parents say something, and they're like, you need to get your homework turned in, and you need to be responsible, and then your parents aren't responsible, right? And they're contradicting themselves, right? So what we're going to do is we're going to contradict ourselves. For science! So what we're going to do is we're going to say, we're going to assume. You know what assuming does, right? Makes a and, right? So we're going to assume that these are not concurrent. Thus my drawing, right? And then we're going to prove that that's just silly. That can't be true. That's impossible. It would be impossible for them to not be concurrent and for this to be true. And so therefore, what we assume must be wrong. So we're going to assume the opposite, prove that that's wrong, and if the opposite is wrong, then the original must have been right. Evan, are you alive? What is going on? There's an easy one after this. Do you want to do an easy one, or do you want to go to this one? Easy one? Okay. We'll come back to 3. Is that okay? All right. Evan wants an easy one. Dude's got to catch a break. Had a rough day yesterday. Getting bullied. Girls in this room, they're awful. They're really mean. But Evan was great. that kid. Absolute legend. Also today, I put you in my trio. Do you know Thomas Schlaffer? Okay. I don't know if you think he's funny or not. I think he's hilarious. Parker Boren. Okay. You are in the trio of funniest kids in the school that I know.
Cool.
You are up there with them. Even though you squirted that bottle in lunch and got water everywhere.
Yeah.
That was actually kind of funny, but I couldn't tell you that because I had to be a teacher and be like, no.
Yeah.
Okay, good. So we're good? We're still cool?
Yeah.
Okay, good. All right. You're still most gangster. You and Chloe Rader, Austin Rader, most gangster in the school, hands down. All right. I have opinions on everybody. Keaton, I can't tell you.
What's my?
I don't want to know.
I have opinions.
All
on
good
everybody,
things.
too.
All good things. Okay.
I mean, I have opinions.
Do you
I'm kind of
dislike
annoying.
anyone?
What?
Do you dislike
I hate
anyone?
everyone equally,
Sounds about right.
and that's how I win.
Mr. Weston said that.
What is wrong with that guy?
A lot.
Okay. All right. Like this is a bit. Like this is an act. Like, I play a character on it.
You're not on the story.
Mr. Weston
And
is
now
like,
I am, and I'm playing a character.
he tried to get me expelled.
Really?
Yep.
For what?
So have I. Okay.
In my math
Imagine a
class-
world where I had no students. Would I be here right now?
No.
I feel like this is a worthy cause. All right, so we're gonna prove medians are concurrent of a triangle. So let's create some medians. What's a median?
The middle of something.
I got extras. What?
The middle of something.
I mean, kind of, yeah. Kind
It's
of.
the
Line segment median.
It's
The
the
vertex is the-
vertex that like
to the-
what's the
Vertex to
Opposite side, yeah. Vertex to midpoint. Very good. Yeah,
I
yeah,
can't
yeah.
find the
So I'm
whole
gonna
thing.
draw a vertex to midpoint. There's a vertex. Here's a midpoint, so says I, right? Every line has a midpoint. Every line can be cut in half, right? So let's just have D be the midpoint, right? It's somewhere. Let's just say it's there. Okay? It's fine. Estimation is fine, if you have to. Okay. So we're gonna say let AD exist, and not just it exist, but also let it bisect the opposite side. In other words, we're gonna say that CD is congruent to BD. So nothing. Cool. Let's draw another median. Evan. I'm gonna connect B to this side. I'm gonna call that a midpoint. What do you want to call that point? What letter?
C.
Or do you see?
E. That's
E for Evan. Right.
Did you just call her a
No. There's no proof of that. It's a joke. We're live. Alright, hey YouTube. Alright, so. Am I right? So we're gonna say let BE exist.
I'm kidding. That's a joke.
I didn't know what you said, but I hope it was okay. Okay.
I made a joke.
Okay, that's fine. I'm fine with jokes. Alright, so BE cuts this side in half. What letters am I gonna use? Evan!
What?
What letters am I gonna use to talk about these sides?
I don't care.
No, you do. That's why you're here. What side is this?
CE
Thank you very much.
and EA.
A.
It's not in the game. We do alphabetical order. Sorry. Thank you. Okay. And lastly, I'm gonna draw my other median. Now, we know medians always intersect at the medicenter, right? Or centroid, okay? But I can't assume that. So when I draw mine, I'm purposely not gonna go through here. If you go through there, I don't care, right? But we're not gonna assume that. We're gonna prove that actually it does all intersect at a point. Isn't that ugly? All right. I've used D, I've used E. What's the next one?
Can we call it N?
N for Natalie.
Little Natty.
Lil Natty. Shout out to Lil Natty.
I thought you said Lil Maddie earlier. That was confusing.
So let Stn exist
Natty.
and have it bisect the opposite side. So AN and BN are going to be congruent, right? And the good news is that now we're basically done. Almost. Here's why. Because when I go around the circle, I'm going to have AN divided by BN. What's AN divided by BN?
A over B?
Little a over little b, right? I could put that on there. But what's AN divided by BN? Think about it, think about it, think about it. What's going to happen when I divide these two?
1.
It's 1, right? They're the same length. Times BD over CD. What's that going to be? 1, because they're the same length, right? Times CE over AE, which is going to be 1, because they're the same length. Thank you for medians. We love congruent segments. So the writing is a little crazy. So I'm just going to go, look, AN over BN, I'm going around the circle here, times BD over CD times CE over AE, and I have to prove that A equals 1, right? If I go around the circle, if it equals 1, right? Then I can prove they're concurrent. So here's what I'm going to do. Isn't AN the same as BN? So they're substitutable. So I can write AN over AN. And instead of writing BD over CD, I can write BD over BD because CD and BD are the same thing. Are you with me still? Key 10. Don't answer. Don't answer. Just think about it. CE and AE. They're interchangeable, right? So I can write CE over CE. Now, this proves, like I was saying earlier, right? They're all going to be 1. Because anything divided by itself is 1. And if you look, something divided by itself, something divided by itself, something divided by itself. 1 times 1 times 1 is 3.
Are you going to practice?
I don't know if I'll be able to.
Why?
I'm going to help you right after this. I'm almost done with this one.
Because I have to do my review.
So,
I'm not in this.
they all multiply to 1. We cool with that? Now, what does this mean? Well, by the thing we didn't prove yet, Seba's theorem's converse, if they all multiply to 1 when you go around the triangle, they were concurrent. So last bit is Seba's theorem's converse. Medians
60.
of triangle ABC
We're running 60 too.
are concurrent. They do all intersect at one point.
Oh.
We win. So the Medi-Center exists, which is good because it's the center of balance in a thing. And everything has a center of balance. Like me when I have a pizza in my hand and no grading to do.
You have a pizza.
I did have a pizza.
Oh
I
my
gotta
god.
go.
Okay. Bye, I'll miss you.
I miss
See you,
you.
little Natty. You want to take a break, or what do we want to do? Who wrote an L on this? Who wrote an L on this?
Take a textbook cleaner and wipe it off.
Corinne, I don't want solutions. I just want to vent right now.
I get it.
Thanks. I knew you would.
I do that a lot.
I know. That was the joke. All right. That's it. That's the tweet, as they say.
Why do you draw little boxes?
When you end a proof, in college or professionally, you do a single box. Like, and that's where we get boxing our answer from, right?
Oh,
Also, you do Q dot E dot D, which is Latin for basically proofs in the pudding, right? I don't do that. So what I did is I did one box, and then I was like, swag box, 2 boxes, and then I was like, swag Q. And it's been a thing.
okay.
This is all
It's what the
making
people
me
want.
question whether I want to actually go to college and like be a dietitian, or if I want to just go to flight attendant school and make money like that.
But you know what's great about life, and it's awful at the same time, is that you don't really get to choose just one path. So do what you want, and if you don't like it, change.
Flight attendant?
You could be a flight attendant at any age. I've seen an 80-year-old on United Airlines.
Find out the path that works best for you,
Well, on
and it'll
American
adjust.
Airlines, like
I was
they
gonna
make
be
a
a
lot.
music
Well,
teacher.
it's an
I was
expensive
gonna be a preacher.
airline, so they make a lot of money.
Should we take a break or keep going? Because it does no good for me to do the same thing I do in class when you guys are like dead, right? So you want to take a break and then come back, or what are we doing?
Yeah. Okay, because I don't understand this. Like this half.
2 things about medians we know. Actually, a couple things. My capital kids. Oh, geez. This is gonna help Corinne. What do we know about medians in a triangle? What do we
They
know about medians?
bisect the opposite side,
Yep.
but like it's just the equation goes.
Right? And then what else do we know? Before this is for them and you.
Maybe sometime.
Medi-center, right? Center of mass. What else? What about how there's cut?
Isn't it like the center of a triangle inside the?
Nope. doesn't have a center, or a circle.
Oh yeah.
Right? So 2 to 1 ratio is going to help you out. Don't do this.
Oh like. And then that one.
This one?
And that one. Like these three.
Okay. So,
Like I forgot.
so for this thing is 3.9, right? Okay. So we know whatever this is, we'll call it x, and we'll call this 2x, right?
Yeah, I just don't know how to get to a point where you figure out which is which from, because this isn't split in half. So I can't just divide it by 2. So I
Believe me,
don't
believe me,
know
believe me. Medians are always 2 to 1 ratio. So that's twice as big as this guy. I don't know what either are, so I'm calling them x. Does that make sense?
Yeah.
Little guy's x, that's double x then. All together they make 3.9, right? See what almost happened there?
Oh.
And now I know what that is, and now I know what this is, because I just doubled it, right? Does that make sense? Okay, cool.
Yeah, I get that, but, so that's just, that for these two,
Mhm.
so this one's
You're gonna have to get clever with the algebra. I'm sorry that you didn't have algebra with me, and I'm sorry that geometry is basically algebra 1.5. That sucks. Are we good?
No.
Keaton always looks like this. What about you? Are you good? No? What's happening? What can I do?
I don't know.
You need to like run around, get height.
I run with the track kids. Why aren't you in track? You should be in track. You're good at long distance.
Don't you guys have a meet tomorrow?
Yeah.
Is this
Where are you
tomorrow?
running?
She just told me that I'd be in the 60 and the 200.
The 60?
Yes. Well, it's in no, it's an indoor meet.
Who did I give the
Oh,
envelope in
so-
your class?
Landry.
Okay.
Landry? Okay.
What's the envelope?
What up? Muy bien, I guess.
Don't worry, no Spanish either. What's the envelope?
When people say muy bien, they really mean on the inside. Hey, you just gotta pretend.
Yes, LOKO.
What should I eat for dinner?
That's all I got.
Is that dark chocolate?
Mm-hmm. Cacao.
What's cacao?
It's cocoa, but fancy. It's dark chocolate. I have a bunch of these. I accidentally ordered one. I thought I was ordering one for my mom for Mother's Day, and then they sent me a box of 10. And I'm like, great. Now whenever I forget a special occasion. But yesterday I was hungry.
How much was it?
I just thought it was fancy chocolate. You pay. It's Mother's Day. You don't ask how much it costs. You just buy it. Okay.
Well, like, if you pay like $50 for a thing of chocolate, you think
I
something's
think
wrong.
the issue is that you think I'm intelligent, and I'm
Oh, yeah.
not. And that's the flaw in your logic.
Well, you're teaching math.
You know what I saw?
I'm not even a real math teacher.
You know what I saw? It was really funny.
What did you see?
This person was like interviewed or whatever. Well, it was just a Twitter thing, but
Corinne, if it were anybody else, you'd take way too long to talk. And they're gonna have to speed it up to 1.5. And if they do that, they're gonna lose their minds when I talk. I'm sorry. It's for the views, okay? Like and subscribe. Alright, so triangle angle bisector theorem, tab. Okay? So what it says is that if you have a triangle and it's got an angle bisector in it, what does it mean to be an angle bisector, Keaton? What does it mean? Yeah!
Splits the angle in half.
Yeah. Boop, boop. AD bisects angle BAC. That's an angle bisector, Keaton. No. You have a comment, Mr. Scott? Okay. So, it says that if you bisect an angle in half, the sides of that angle will be proportional to the bases they create the triangle. Okay? Now you're like, wait a minute. Similar triangles, right? Maybe. Here's the thing, you're never going to get these similar because you need how many angles to prove similar triangles? 2. If you get 2, you get the third one for free, right?
True.
But 2 pairs, technically 4 angles, but yes, 2 pairs, right? And I only have 1 pair. So, here's what we're gonna do. Big brain play. We're gonna create another triangle. We are going to birth a 3-cornered polygon right here in this room. We have no time to make it to the hospital. It's happening right here, right now.
That's scary.
How are we gonna do it? Well, we're gonna take out our professional tractor. Pick them up at Farm and Fleet. Please subscribe. We're gonna make a line that's parallel to one of these guys. Either X's line or Y's line. Either angled, right? The side of the angle, the rays. So, I rate. Which one do you want to draw parallel to? You want it to be parallel to AC or parallel to AB? Your call.
AC.
AC! Nice. Okay. So I'm gonna draw a line that's parallel to this, and I'm just gonna like I'm gonna do that. It's totally gonna be parallel. I really hope you wouldn't choose AC because I'm gonna run out of room. Where they intersect is like way over there. Okay, so we're just gonna keep going. Okay, cool. Off the page. So I'm gonna create that line and it's gonna be parallel to this guy. And we need to get angles, right? So having like parallel lines is a good idea because parallel lines get you lots of angles. So I'm gonna extend this angle bisector. And where they connect, where it connects with the green line, that's gonna make me another triangle. Oh, that was sick. I didn't do that on purpose, but that was sick. Alright. No, you go here. Okay. So I'm gonna say where they intersect. I'm gonna call that K for Keaton. Respect. Game, respecting, game. I'm gonna call that Q for never quit. Okay? So let there be, let BK Q be parallel. What line did I make it parallel to? Evan, what line did I make it parallel to?
AC.
AC. And extend this line such that ADK exists, right? And they both have K in it, which means they intersect at K. Yay! We showed it. Okay, now we've created another triangle, a new triangle, freshly formed. Okay. We need to get some angles over here to be congruent over here. Well, I only see one angle, so how are we going to get this angle to show up over here? We've got two parallel lines and a transversal, right? Do you see it? Yeah? What are we going to use?
Corresponding.
We could, because corresponding here and here, right? Like this would be corresponding, right? And then we use vertical to get that. This is a shortcut instead of doing corresponding then vertical.
KDB and CD.
Yep, these two angles are going to be the same by two parallels cut by a transversal. In between the parallels, opposite side of the transversal,
Or,
alternate interior angles theorem.
no, I was saying KDC and
KDC.
no, KDB and ADC.
Ooh, yeah. So these will both be congruent by vertical, right? That's true. That's true. We're going to do that next. So I want to point out our alternate interior because those are the ones you really need. And they're harder to see. Alternate
See you,
interior
Matt.
angles theorem. Bye. Best of luck at your. Yeah, I thought you were at oh, you were working out. Got it. Okay, cool. Alternate interior angles.
My sister decided to start watching the whole Barbie franchise 100 times. Like she literally said, I'm gonna watch it 100 times by the end of this year. It's wonderful.
This is what I go through. Listen up. I have a Patreon. Okay, so these two are congruent. Let's write those angles. Angle CAD is congruent to angle DKB. Awesome, good. Letters, I hate them. All right. Other set of angles. She's right. Vertical angles here and here, right? You could have also said alternate interior here and here. It's up to you.
Theorem.
What? Scissors theorem. Your words, not mine.
Is that only my class?
No.
Okay.
Oh, sorry guys, bad news. We're leaving Q behind. By vertical angles theorem, which I almost always do in green, but not for this problem. I have no idea why. Vertical angles ABC congruent to angle BDK. And to be clear, I have no idea why I didn't do it in green. I know why I normally do it in green, because vertical V is a green letter for me, and I don't know why. So, now, we've got two angles in the triangles. So we have enough to prove them similar now, right? So we should do that. That triangle is similar to this triangle. So by double angle, right, since I have those two angles, triangle ACD, we do alphabetical when we can, is similar to triangle. Let's match them up. Angle A in this triangle is going to go with what angle in this triangle? Even! Angle A in this triangle is going to go with what angle in this triangle?
Okay.
K. Leaves me on red, then responds with K. Alright, fair enough. C.
B.
D. Very good. Okay, so these triangles are similar. If they're similar, then we should be able to match up their parts by CSP, right? So AC and KB should be proportional, right? Because they're both first and second. What is AC? It's X, and KB is O. Well, we wanted X with Y, and there's nothing over here. How do we know that this is Y? What do you see? Think big picture. What do you see? What do you see? An isosceles triangle, right? Two angles the same. That means this is isosceles, which means these two sides are the same. Is that the theorem or the converse of the isosceles triangle theorem? Converse, right? Because we start with the angles and it gets us a side. So, zooming out, by isosceles triangle theorem converse, we know that AB and BK are congruent. Which means that BK must equal what? If AB equals Y, what is BK going to equal? I ask the questions. Thank you. So, now we can do CSP and they're going to match up. By CSP, these go together. Corresponding similar parts, right? They're corresponding because they're first and second position, right? And they're going to be similar because the triangles were similar, right? So, by CSP, I know that AC and KB go together. But what is AC? Well, AC is X, and KB is now Y. That is good. And then also, CD and BD go together. Well, CD is what? Little A, and what's BD? Little B. Swag bucks. When I used to teach, I'd teach up on the board, and I wouldn't sit, and I'd be less fat because I get more exercise. Also, I would spike the marker when I was done with good proof, and it would explode over the floor, and the janitors hated me, but now they love me here because I sit down. Far less exciting for you, less calorie reducing for me.
But Danny DeVito looks like the Lorax.
Danny DeVito is our god, and he played the Lorax, so that makes sense. They made the Lorax look like him. Please respect my religion. Questions? Here's what we did. We drew a parallel line so we can get more angles, right? We extended this guy so we can make a triangle. We got vertical, we got alternate interior. That's an isosceles triangle. Similar triangles, boom, we get our stuff. Would you know how to do that? Would you be like, oh, let's solve it this way? No, right? Some really smart dude came up with this method, but this is the easiest method to prove this really cool theorem, right? Because we're going to use that theorem to prove that any angle bisector in a triangle, if you draw all three, they'll be concurrent. Okay? How do you feel? You want to digest? You want to break? You want a snack? You want a treat? You want a treat? How's your puppy?
He's great. He needs to learn that.
That's what I said about my kids the other day. They need to learn.
We he's trying to do like puppy play, which is fine, but that also means like he tries to gnaw on your hands, and we don't want him to do that.
So he's a puppy. Yeah.
Yeah. He's very wild for a mastiff. Mastiffs are like supposed to be lazy dogs, but he's very outgoing.
Yikes.
Which is fine. I mean, he's cute.
If you be one thing, guys, not smart, not wealthy, cute. Get away with anything. One thing. Look, I'm smart, right? Supposedly. Look where I am. It's 4:15. It's Thursday. I was awake until 2 a.m. last night making this thing, and I'm getting paid very little.
But you're
Hang out with a
eating
bunch of
pizza
ice
and
blues.
chocolate.
Okay? You what?
But you're eating pizza and chocolate.
This is true. This is true. With money I don't have.
Good chocolate.
Rent was due yesterday. I gave him a check. Hopefully it doesn't bounce. All right. So, again, be cute. Don't be smart. It's a waste. This is stupid. Waste of time. Drop out. Drop out. Drop out.
Flight attendant.
If you drop out, I don't have to grade. Right?
But if they drop out, you won't have a job.
If everyone drops out, no teachers will, and then we'll have a communist revolution, because no one will have a job or money, and then we all win. Stop being selfish. Drop out. Take one for the team. Okay? Take one for the team. You ready? Okay, Even's not ready. We're gonna wait. We'll wait, Even. We'll wait.
I'm ready for these.
Wait. Oh yeah, I'll do.
I already failed this test.
You what?
I already failed this test.
Who'd I give the envelope to in your class? Were you first hour? Oh, first hour didn't get an envelope. Keaton. That's why I have an extra. Keaton, you're getting an envelope, Keaton.
What's in it?
Oh no, I gave it to Shelby. I gave it to her after she said later. I can't tell you what's in the envelope.
Why?
Is it?
What's in the box? What's in the box?
Are we gonna get
It's
to
not
find
what
out
it tells us,
tomorrow?
I'll tell you that much. What?
Do we get to find out tomorrow?
Yep.
Alright.
I wrote these things a while ago, and I gave them out to each of my class, and they say the same thing. You know I didn't doctor it because I gave it out to individual people, and I couldn't change them all. They would say, it's a secret. So stop whining, focus on the stuff that you do know, and in the stuff that's just past that, work on getting that tonight.
Good.
Okay? I'm not going to tell you you're going to pass this thing. What I am going to say is that you're going to attempt to get better than what you were before. And I highly encourage you to do that. Highly encourage you.
So what he's saying is drop out.
Okay.
YouTube asks you now if this video is made for kids, and I have to say no every time. Safety first.
Wait,
All right.
really?
Yeah.
Like you put them on restricted?
I put them on not made for kids. There's a difference.
Oh.
So for kids, their algorithm, right, it won't be in there, but it's not restricted. All right. We're going to prove that the angle bisector of a triangle are always concurrent, otherwise known as proving that what exists, what center. Angle bisectors make what?
Angles that are similar.
That's the orthocenter.
Right.
Text.
Angle bisectors, what center do they make? Woo boy, in-center, very good, right? Which is the center of an inscribed circle, right? So we're going to prove that the in-center exists. That there's a point that's equidistant to all the sides, which makes sense. There probably should be, right? So we're going to prove that. Here's what we're going to do. We're going to create some angle bisectors. Even, what is an angle bisector?
What?
Take your time. What's an angle bisector?
I don't know.
Clip that, put that on my ASMR channel. What?
I don't know.
Okay. An angle bisector, which you told me earlier, was something that cuts the angle in half, right? Splits the angle. Pray for these children.
What?
Pray for these children.
I'm not religious.
It's just a joke, okay? Alright, so I'm going to draw an angle bisector. Boop. I'm going to say that cuts the angle in half. Oh man, that's good looking. Wow. Alright, we're going to call that AD. Why? It's the next letter in the alphabet, Ethan. Evan. Whatever.
That's what Ricky calls Ethan.
Let AD exist. And not only let it exist, but let it bisect this angle, CAB. You can say let it bisect CAB, or you can say that CAD is congruent to BAD. What do you want me to write?
Oh, this isn't my class.
Good question. Okay, fine. Am I doing this for me, or what are we doing here? Angle CAD. Because trust me, I know this stuff. I've done it like 8 times just today, this entire packet.
That's
Okay.
too much.
No, I want to go home, but it's okay. I'm here for you guys. It's my favorite part of my job. All right, now I'm going to create another angle bisector. Boop. So I'm going to create segment BE. two angles that are congruent. ABE. Angle CBE. Cool. Alright. And one more. Now again, we're going to prove that they're concurrent, so I'm not going to draw it through here, even though we know it will, right? Because the incenter does exist. I believe in the incenter. Do you? You probably know. But it's real. I can prove it. Okay. So I'm going to create this guy, CF. Angle ACF is congruent to angle BCF. Cool. Evan, get off the phone. Like, why are you here if you're not going to really be here? Like, it's not an angry me. I'm just like, dude, go home. Right? If you're going to be here, and if not, then, like, go home and have fun or something. Right? Like, at least in school, you have to be here. What's wrong with you? All right, so I created a bunch of angle bisectors. We good? Awesome. Cool. We're going to prove they're congruent. And we're going to use angle bisector theorem. TAB. Remember that? That's the thing we just proved. TAB theorem. Triangle angle bisector theorem. It says if you have a triangle and you have an angle bisector, right, then the sides of that angle will be proportional to their bases. Okay? Cool. So, Keaton. Isn't that an angle bisector, Keaton? Okay, so this side, these sides right here, are x and y. And they're going to go with their bases, right? So instead of saying x and y, I'm going to say CA and CB. Does that make sense? No, it doesn't. I didn't do it alphabetical. AC and BC, right? So AC over BC is going to equal the bases. So AC and BC, the bases are AF and BF, right? Are you with me there? Sides, bases, right? Sides, bases. AF and BF. And again, this is by triangle angle bisector theorem. Cool. I'm going to do that for all of them. Keaton, isn't this an angle bisector? Okay, so these are the sides of the angle that's been bisected, right? So AB and BC. And AB and BC open up into these two bases, so AE and CE. Lastly, I did the blue, I did the green, I need to do the red. Angle bisector, yeah? So AC and AB. We'll do AB first. AB and AC opens up into BD and CD. Okay? Now, we're going to prove that these lines are actually concurrent, that they must intersect at one point, not like this. Okay? And the way we're going to do that is we're going to show that, look, AF times BF, AF over BF times BD over CD times CE over AE all equals 1, right? So I'm ready to do that now. I'm going to write AF, going around the circle. What's next? BF. Letters are hard. Next. This is the part of the show where you play along.
DB.
I'm sorry?
DB.
Say it again.
DB. BD.
Thank you. And what's next, Keaton? It's a C.
CD.
Very good. Next.
CE.
And
AE.
I love how you thought about which came first in the alphabet for CE. That was great. I appreciate that. I felt that. All right. Now, we're going to prove that that equals 1. Okay? Well, don't we know AF over BF and what it equals? We do's. It's AC over BC. And don't we know what BD over CD equals? We do's. It's AB over AC. And don't we know, whoops, AC. And don't we know that CE over AE, this guy, be careful, it's flipped. CE over AE will be BC over AB. Right? And now, what's AC divided by AC? What's AB divided by AB? What's BC divided by BC? Oh my god, it's 1. It's 1. It's 1. So if this is 1, if the way the triangle is divided up all multiplies to get 1, then they must have been concurrent by Sieva's theorem's converse, right? Sieva's theorem says that if they're concurrent, then you get this. The converse says if you get this, then they're concurrent. By Sieva's theorem converse, we know that the angle bisectors of triangle ABC are concurrent. Loaf. I'll zoom out. First we made angle bisectors. Then we did tab theorem. Then we went around the triangle and substituted. And then we won. Are they Sievians? Yes. Then we're going to use Sieva's theorem's converse to prove that they're concurrent. Okay? How do we feel?
I'm lost.
Okay. Do you know up to here? Okay. What about here?
No.
Okay. Tab theorem. It says if this, right, x over y equals a over b. Right? Angle bisector. These guys, x of y, right? X over y, a over b. AB, BC. This one, right? AB and BC. We'll go with these two.
I don't see it.
Yeah? And I use big letters. I do it for all of them. These two sides, these two bases. Right? Okay? These two sides, these two bases. That's what I did. And now I'm going to go around the triangle, right? That's that. What is AF over BF? Right? What's BD over CD? What's CE over AE? It's this one flipped, right? Flip, flip. What did you say?
I don't know.
And then they divide and we get one, right? Uh-oh. Evan, look out. They're back. The bullies are back, Evan. Evan, get out. Run away, Evan. Hi.
Okay, bye.
Oh, bye.
I would stay, but I can't.
Okay, well, thanks for stopping by. Alright. That's triangle angle bisector theorem. Okay? Ready for an easy one?
Yes.
You want to take a break first or do easy?
Easy.
Alright, Corinne, can I help or what should I do? I'm losing track of you, I'm sorry.
I forgot to do this.
Do you want to go home?
Yes.
It's a solid 5 out of 10. You good with that? Or do you want me to help? What do you want?
No, I want to give
Okay.
explanation of it.
Okay. GE is 3x plus 5. And IE is x plus 6. So, if this is a median, that means this is congruent and that's congruent, right? So x plus 6 doubled will equal 3x plus 5, right? Or x plus 6 plus x plus 6, whatever you want to do, and you solve. TP, later. Bye. I'll miss you all. Especially you, Keaton. Goodbye. TQ. I'm gonna get to the home early today. Just 3x minus 5. Sorry, this is the answer key. So we want to find x. Well, both of these are equal, right? Because they're medians. And they divide this side in half, right? That's midpoint. So on and so forth. Okay. ET is 3x plus 2. And EM is 5x. So this thing right here is 3x plus 2. And the whole thing is 5x. So I know that 3x plus 2, so whatever this is going to give me 5x, right? Okay. Well, isn't this always half of that?
Yeah.
So if I have it, it's 3 halves. 3 halves x. Okay? It's going to be weird if you do it. And that's the last one. Sorry to make you wait.
So
Oh, hold on. You'll need to get common denominators to add those together, right? Yeah. This would have been better than a 5. I forgot I took these off, but I think you can do it. Yeah.
you all lose.
Yeah, let's look at this. Quick break. Sevians. I had a bunch of those. Is that from the review packet or is it from the homework?
Homework.
Okay. Sorry. Had very little time to organize. I have one worksheet still left. Alright, so let's talk about these real quick, and then we'll get back, okay? So this is the homework, yeah?
We had homework.
No, not you, them. It's very similar. Alright, so check it out. What center must G be? In center, because angle bisectors, right? And in centers have radii, so that must be a radii, and that must be a radii. So x is going to equal what?
5.
5. Good. Now, is y a radii? Is y a radii?
Angle bisector.
It's an angle bisector, so we can't just do that thing, right? Here's how we're going to figure it out. You see these right angles?
Yeah.
You should be looking for Pthag. So this triangle right here is a right triangle. So we can do Pthag and figure that out. Is y the hypotenuse or a leg? Hypotenuse, right? Across from the 90. So we do 5 squared plus 12 squared equals y squared. That's 25 plus 144. 169. Nice. Which means y is 13. If you didn't know 13 squared was 169, you do now. Okay. It says G is the circumcenter. All right, think. When the circumcenter is on the on the triangle, what kind of triangle must it be?
Right.
So this is a right triangle. Right, acute's always inside, obtuse would be outside, so it must be a right triangle. Now, what kind of line segments make the circumcenter? Perpendicular bisectors. Yeah, easy for you to say. Yep. So this must be a perpendicular bisector, right? Because they make G. So if that's 3, what's x?
3.
And if that's 4, what's y? Careful. 8. Good job. Now, how are we going to figure out z? 2 ways. 1, if this is 4, and that's a right triangle, right? So that's 5. Same thing here. Or you say, look, this is a right triangle, right? Pthag. So I have 6 squared plus 8 squared equals z squared. Right? This is 6. This is 8. Are you digging that? So I get 36 plus 64 equals z squared, and that adds up to 100. What's the root of 100?
10.
So z is 10. You are praying these are on the quiz tomorrow. You are praying. Earlier you guys were like, please, no, please. I put these on here to save your grade. You gotta know your crap, and then they're easy, right? If you don't know your crap, they're impossible. And that's the kind of questions I ask. G is the medicenter. You've seen this stuff. G is the medicenter. So what kind of line segments must these be? Medians. What do we know about medians?
They bisect the angle.
Not the angle,
Or the side.
the side, right? They bisect the sides, right? Midpoint, right? Midpoint to vertex. So this is true, and this is true, right?
But the insides are like half.
Yeah, half and double, right? 2-to-1 ratio. So here, right? If this is 3, this is 3. So what's y?
6.
Good? Ooh, this is a tough one. This is a little bit there's a little bit tougher. Okay, so ooh, can we do this one? Hold on, I might be missing a little bit of information that I need. Let's just start labeling stuff. This is 5 and this is 5, right? Definitely. Am I missing a little bit?
Across from the 5 is 10, across from the 8 is 4.
Across from the 5 is 10.
Like.
Oh, 5 and 10. Oh, sure. Yep, thank you. Sorry, it's getting to me. That's 10, right? 2-to-1 ratio, right? Are you digging that, Evan? 2-to-1 ratio, remember for medians? So if that's 6, this is 3. That's true. And if that's 8, this is 4. Yeah, we can't do this one. That's okay. I screwed up the diagram. What was going to happen is I was going to have that be an 8. And if those are both 8s, and this is an isosceles triangle, right? And if it's isosceles, these angles are the same. And it's equidistant from the endpoints, right? Remember isosceles triangle theorem, converse, right? We get the sides the same, right? But that messed it up. And if it's equidistant and it's at the midpoint, then that's 90. Perpendicular bisector theorem. We haven't reviewed that yet, but it's true. And if that's 90, we can use p-fag to figure out x. That's a really tough one, but I screwed up the problem. Sorry. I think I gave them the hard one and you guys the easier one. Sorry. I had 2 documents open up. One was a harder diagram, same thing. And I think I gave you guys the harder one.
Yeah,
Oh, I definitely did. Is this what you have? It is? Yeah, I definitely screwed these up.
Yeah.
This was meant to go to you guys. Yeah. Because you guys had a god awful looking one. You guys did it anyway. That was impressive. Oops. Oh.
I'm missing.
I'll shut the door so they don't hear you or see you. You in trouble?
No.
Okay, good. Alright.
I'm missing out on abs.
You be doing it right now. Why are you slacking? Do both. Also, you work out with your mom, so you're totally good, right? Alright, so,
Tomorrow morning.
similar triangles, right? By cap, right? By cap, right?
Yeah.
Cap. So we know they're similar by double angle. So we know,
I didn't get that one.
you didn't get this one? Number 4? You have a different one? Oh, yeah, your first hour. That's okay. You don't need it. You're fine. Just watch, okay? Remember my Microsoft Word wouldn't save. It deleted stuff, and I'm sorry. But you're okay. Less work. Okay, so just watch and you'll get it. So, small triangle has 3. Big triangle has what? What is that in the big triangle? 10. So 3 to 10 is 1 ratio, right? And then we have 6 to what in the big triangle? 6 in the small triangle goes with what in the big triangle? Oh, are you trying to figure it out in your head? Don't do it in your head. Don't do that. Right? X. And now we solve. Multiply by 6, right? What's 6 divided by 3? Times 10? Not everybody can do it in their heads, okay? Alright, and that means y to 40 also is the same ratio, right? 3 to 10, it's going to be y over 40. Yeah, I gave you guys like hard worksheets.
Why is x is equal to?
Didn't we do this one?
You did this one like a couple days ago, I think. Yeah. What did you say?
Why is x equal to?
Small triangle to big triangle. Small triangle to big triangle. Small triangle to big triangle.
Yeah, but why?
Oh, you're telling me the answer? What's the answer?
I thought it's 20.
Oh, I'm sorry. You're right. Apparently I can't do it on paper. You go home.
I'm gonna go home after this one.
Good idea.
Yeah.
Why is it 12?
You
I
were
didn't
over.
see.
Oh, I'm sorry. Times by 40, divide by 10 times 3. Ready for 5? 5 is a bit of a challenge. Orthogonals, right? What do we know about orthogonals?
I have 90 degrees.
Orthocenter, 90 degrees, and they also create similar triangles. You might not know this. Vertical angles here and here, and since this is also 90, and this is 90, these two triangles are similar by double angle.
So
Right?
aren't they the same?
They're very, very similar. So, they're similar by double angle, right? So, the hypotenuse on this one is 5, right? What's the hypotenuse on this one? 10. And that should be equal to the leg on this one, x, to the leg on this one, y, right? And then the bottom, 3, should be equal to z. Okay? So we can solve this one, right? This one right here, Evan? We can solve that one, right? So 5, let's do 10 over 5 equals z over 3. Well, think about it. 10 over 5 is a 2 to 1 ratio, right? So what's z going to be? 6, right? Multiply by 3 over, you get 2 here. 3 times 2 is 6. So z is 6. Looks like 6, right? That's 5, that's 6. Checks out. All right, how are we going to figure out y? Pythag, right? 6 squared plus y squared equals 10 squared. Y is 8. Are we going to find x, Pythag, or plug it in, right? We've got a 3 something 5 right triangle. It's 4, a 3, 4, 5, right? Because 5 is the hypotenuse. So x is 4. These can be hard, but once you see it, it's like, oh, okay. Right. There are going to be a couple of these on there. How do you feel about that? My advice is the same thing as basic geometry. Look for right triangles, Pythag. Do not forget Pythag, okay? Also, similar triangles, right? Know your centers, because then you get a lot of stuff for free. Like, if you know that's the incenter, you know those radii, so x is 5, right? That is not hard. Figure out y again. Don't forget to look for Pythag, right? To figure out that guy. That's the key, okay? Oh, of course, you can have this. I'm just gonna throw it away. There you go. If you guys leave, what I will do is I will run through this entire review by myself from the beginning, without interruptions. Straight through with commentary. As if kids were in the class but didn't ask questions. This took a really long time because you guys needed a lot of help, right? So I'm sorry that took so long. Also, I was being goofy because you guys were just like dead.
I also haven't figured this out completely.
You got what?
I got to the denominators. It's 6
Mhm.
and 2 and 2.
They're halves. Same denominator, you keep the denominator. That's 19 halves.
Okay, but then still, like, I don't.
Okay, so, yeah, this is one of the harder ones we did try. So.
And that's not 16, this is the one from the other.
Oh, okay, 6 halves? Okay, so that's 9 halves, yeah. So what we're gonna do is we're gonna move this over and get common denominators over here. Sorry, I'm writing it down.
Oh,
Okay,
sure.
get common denominators, and then you're done, basically.
Wait,
Bottom's still there.
This, yeah.
Thank you.
so just 5 over 2.
10 halves, right? Yep, yep. 10 halves, not 5 halves,
So-
10 halves.
Bye.
5, 5. Well, we've been taking our sweet time. Yeah. Oh yeah, bye. See you in a few hours.
So-
Ten halves minus 9 halves.
So,
Right. If I had 10x minus 9x, you wouldn't hesitate, right? Right, so it's 10 halves minus 9 halves x, right? It's just
so,
1 half x.
and then what about the 5x? The 5x.
That's the 5x turned into a 10 halves x,
Oh.
right? And so now how do I get rid of times a half? I divide by
So,
a half, which is multiplying by
X
2.
is just 1.5.
Nope. You're thinking about it backwards. How do I get rid of times a half? I divide by a half, right? But I never divide by fractions. I multiply by the reciprocal. What's the reciprocal of 1 half?
2 over 1.
Exactly. So we're gonna double it. X is gonna be 6. That's one of the harder ones. I'm sorry, Corinne. This has been awful. You did a really good job.
That's it.
And also, this is the answer. I don't know if you knew that.
Yeah, I just didn't know, like, because I could see it, I just didn't know how to do it.
I appreciate the work that you've done. That's very kind. You've done great. Proud of you. And let's take this and grade it, right? Okay. And I think that's it. Let me double check and see. That's all we've got.
Do you have like a packet that you already done?
Yes, I will give it to you, okay?
Thank you.
Hold on one second. Thank you for being here.